This is a solder fume extractor. It pulls smoke off my workbench so I'm not breathing it in while I work. To get here, I went through 3 handheld iterations, switched motors twice, picked the version that actually worked best, scaled it up, and plugged it directly into the wall. By the end of this video, you'll know exactly what worked, what didn't, and why. So if you want to build one yourself, you don't have to repeat any of the research I already did. I'll link the files and the parts you'll need if you want to print mine, and the best fan design resource I found if you want to go full Rambo and design something from scratch. I needed 2 things. Something to clear dust off my workbench, and a fan for a solder fume extractor I was planning to build eventually. So I did what I always do first. I opened Fusion 360 and made the rawest possible shape. A cylinder, an intake, a handle sticking out of the side for the electronics. No research, no real design thinking, just get the idea out of my head and see if it worked at all. So this handle was undersized, I hadn't thought all the way through how the battery and charging board would actually fit, and I built it around a 130 motor. The results were fine, not spectacular, moved air, it existed. And every handheld version after this uses the same electronics setup. So let me show you that now because I'm not going to re-explain it 3 times. We're starting with one 18650 battery, leading to a TP4056 charging board so I can top it off over USB-C, which goes over to a switch to turn it on and off. That feeds into a potentiometer-based speed controller, 5 volts, 1 amp, which drives the motor, and all of that lives inside the handle and main shell, which is one printed piece. The handle isn't separate from the body, it's part of the same print. The only thing that changes between the versions is the backplate. That's where the motor and impeller live, and I designed it to be swappable. Different motor, different backplate, same handle, same other electronics. After living with V1 for a bit, I did the research I should have done first. I learned that you want a gradually widening cylinder leading to the exhaust. It gives the compressed air a channel to actually travel through instead of fighting itself on the way out, so I redesigned the body around that. I also fixed the handle properly sized this time, and I angled it parallel to the barrel, which I'm not gonna lie, was partially a function decision and partially because I wanted it to look like something out of Halo. And around the same time, I started looking into whether a stronger motor would make a real difference. I knew the one I was working with was wimpy. I ordered a batch of 280 motors to test against the 130, and I made backplates for both of the motors on the V1 and V2 shells for combinations, the same handle, same body platform. This is also the part where I'd encourage you to actually try this yourself instead of just watching me do it. You don't need my exact files to learn something here, but swapping a motor and testing the result is genuinely a good way to start to understand airflow, and it's a cheap mistake to make if it doesn't work. I'll have the fan design resource that taught me the most of this linked below if you want to start from your own blank Fusion 360 file. So I ran 2 tests on every combination. A dust push test and a smoke pull test, since the smoke approximate what I actually need this thing to do. The 130 motor moved dust about 10 inches and pulled smoke from about 5 inches away. Useful, but not super impressive. The 280 motor was a completely different story. Dust moved out to about 15 inches, smoke pull jumped to 21 inches, over 4 times the range of the 130, for a motor that barely costs anything more. If you're building your own and trying to decide where to spend the money, that's the answer. Spend it on the motor before anything else. After using V1 and V2 for a while, I printed a 3rd handheld shell, with a slightly tighter housing that splits the difference between the two on pressure and airflow. I haven't run it through the same test rig as V1 and V2 yet, so I can't give you numbers on it today. That'll be its own video once I get around to it. But using all 3 versions has taught me something important for the next phase. V2's shell, the wider, gradually expanding one, actually moves more air at the cost of slightly less pressure. And for a stationary extractor that just needs to keep volume moving over a workspace, that trade-off is exactly what I want. So when it came time to scale this up into something permanent, V2's shell geometry is what I built on. If you only build one handheld version off the files I'm linking, I would probably recommend this one. It's the cheapest and fastest way to see this whole process work for yourself before committing to something like a wall mount build. Battery power was fine for a handheld dust blower. It is not fine for something that needs to run for hours at a time while I'm soldering. So the real engineering problem became, how do I power this safely from the wall and build in room to upgrade later? What I settled on was a 12 volt, 10 amp dedicated power supply. Same principle as always. Build something that works now, but leave in space to put better parts in later when I can afford them. First, we start with our dedicated power supply of 12 volts, 10 amps. From there, power goes through a 5 amp fuse and a 30 amp 250 volt main switch before it touches anything else. Safety is always first thing in mind. From there, the 12 volt rail splits into two branches. Branch 1 runs the motor. It goes through an LM2596 buck converter stepped down to 9 volts, then into a beefed up PWM speed controller. This one's rated for 30 volts, 10 amps. Well beyond what I actually need, but it gives me headroom. Right now that's driving a 280 motor. I've actually got a 380 motor sitting on the bench right next to it, ready to go in. I just need to design a new backplate for it. So consider that the next upgrade. Branch 2 runs the electronics. A second LM2596 buck converter steps that same 12 volt rail down to 5 volts, which safely powers the ESP32 and the WLED ring. The rotary encoder, the KY040, runs directly off the ESP32 at 3.3 volts. Two separate regulated rails off one supply. If I ever want to upgrade the motor side without touching the lighting, or vice versa, I can. This whole thing is mounted off of a spring arm, $20 off of Amazon, using a screw adapter mount that I designed to bridge their hardware to my printed parts. The exhaust runs through a 3-inch dryer venting, out a vent adapter, and an outside cover, both of which I also designed. Between the mount, the vent adapter, the cover, and the housings themselves, this build came out to 10 separate 3D printed parts. Everything from the handheld blower research carried directly into this. The shell geometry, the motor selection, even the lesson about not trusting a battery for long sessions. All of it fed into this final design. There are two things I haven't fully closed the loop on yet. I still need to test V3 of the handhelds against the other two, and I've got a 380 motor waiting for a backplate. Both of those are coming in future videos, but for now, if you want to build your own, I'd genuinely start with the handheld versions, either V2 or V3. It's a real project, and you'll learn the same things I learned. It costs a lot less to get it wrong than this one did. Everything's linked below. My print files will be there if you want to build the exact ones that I built. The parts I used will also be there, along with the best fan design resource I found that taught me the most of this, so if you want to start from scratch, you can. And using those links is genuinely the best way to support the channel right now, so if you were going to buy the parts anyway, I'd really appreciate it. They are Amazon affiliate links. I'm Fancy Pants, this is Fancy Pants Printing, don't skip version 1, and as always guys, happy printing.